Okay, welcome back. I've gotten back into R, and I'm just going to show you again how to pick up where we left off. But the first thing, this is very important, is that we always want to change our directory back to the same place where all of our information is. And in my case, I've saved everything to my desktop, so I'm going to click on Desktop and OK. And now I want to open, load the workspace, or open the workspace. This is opening up the data where I left off. So this is very important because if you don't do this, you'll have to repeat the whole process of all the steps you took last time, which is fine. You can also start from the beginning again in case, for example, you identify that there's some mistake and you're not sure where it happened. Then you can retrace your steps and start all over using your script. But let's load our workspace. That's opening up the data with the new variable names that we had. Clicking open. And so here in the desktop, what we're going to see is something called our workspace, because I didn't give it a name. It's just our workspace. Okay, so that's loading our data. And now, but I also want to go back to my original script. And I'm not going to rerun all of the commands because that would undo the data set that I'm working with right now. But I'm going to open that script, and it's the script that I revised. That's the script from September 21st. And I'm going to click that open. Now I want to tile this. And just make a choice whether you want to tile horizontally or vertically. I'm going to tile this vertically. Now we've already gone through the first steps. We've already created the variables. However, I want to just check. So I loaded that workspace. Is it really there? So I'm going to click on Names, Data 1. That's going to see whether it's recognizing the data set. And indeed, we have our original variables, and we have the variables called bullied and always blue tagged along to it. So if I were to go back to the beginning and start all over, then I would be deleting those variables. So we still have that data 1 shortcut. It's still recognizing the variables that we created. Now the only thing we have to add now, we don't have to install the packages again, but we do have to click again on the library (epi-r) in order to run those commands. So we're going to do stratified analysis, and we're going to get the odds ratios separately for different categories of people. So we're going to rerun that. And that's important because otherwise we can't get our odds ratios, risk ratios, and confidence intervals. So we've already run the 2x2 tables. We've already done the matrix. And we've already got our new variables as 1 and 2 variables. So always blue and bullied are variables that we have. Now we're going to see, we're going to look at what the results look like by male and female. And so when you're looking at a variable that you think might either be a confounder or potentially an effect modifier, you want to get stratified odds ratios. And here's how you do this in R. You can simply run the script, but you can replace the variables that I've selected with additional variables, or you can make use of the ones that I have. So if you want to use a different variable, pay very close attention to how the script is run, and definitely if it doesn't work, contact me because I can troubleshoot with you anything that might have gone wrong. So first of all, I'm rerunning the names command just to make sure that everything is working. And here I'm just going to say how many males. So let's take that original variable, how many males and how many females do we have. So we have the variable called sex, key sex in the original data, and it's a 1-2 variable, and we have about a 50-50 split. So this is just to give us the numbers that we start with. Now remember that anybody missing information on either having been bullied or always blue will disappear from these numbers. So we're going to get stratified odds ratio, and we're going to have it stratified by bullied and always blue, and then we're going to get information for males separately from females. So that's what the first command is giving us. So It's asking for a 2x2 table stratified by the third variable. So that third variable can be changed if you want to use a different variable, and I have already a number of examples here. I'm starting with the example for male-female, 1, 0. The row names will be given as bullied or not bullied, so keep this in your text even if you change your stratification variable. Your column names will be always blue or not always blue, and this is what our stratified tables are going to look like. So the first one is the one condition that's for the males. So you have a 2x2 table for males, and you have a 2x2 table for females. Now taking this, you can already calculate by hand what the risk ratio is going to look like. You'll have to add up across, so it's 10 out of 761 plus 10, so that's going to give you your risk ratio. Or you can simply, instead of doing that by hand, you can put them into a matrix just like we did above. And here you have all the numbers to work with, so you don't have to do any calculations by hand. You can simply create a new matrix table. In this case, I'm saying men, male, odds ratio, risk ratio. Actually, it's a risk ratio because we're looking at this over time, is equal to the matrix value with all of your cells being, and here's where we have our A, B, C, and D, 10, 761, 25, and 2,554. So looking at that 2x2 table, we're going A, B, C, and D with 2 rows and giving it by row across. Giving our row names bullied and not bullied, and our column names always blue or not always blue, we're going to get our 2x2 table. Again, this is just repeating just to be sure that the matrix is working. And then we're going to do the same thing for females, and this is putting it in a matrix format so that we have a single 2x2 table, not a stratified analysis, and then we're going to get the epi 2x2 to give us our stratified odds ratios. So this is for men, and then we're going to get the data for females. We'll always first do stratified odds ratios looking separately at your 2 groups. So we're going to calculate the male versus female, so the male odds ratio here, and these are the 2x2 tables for just males, and I'm going to go down to the command for getting the epidemiological analysis for the men. This is giving us our odds ratios and risk ratios. So here we find that the risk ratio for men is 1.34 and the odds ratio is identical. It's not statistically significant, but it is relevant. The second thing to look for then is to rerun our matrix for females using our 2x2 table information from the stratified analysis. So we have our stratified odds ratio here, and we're looking at the females, that's the 2, and we're using that information 18, 582, 35, 280, 2,804 to get our 2x2 table that we're going to use for the odds ratios and risk ratios. And this is our new 2x2 table. Numbers are exactly the same. And then we're going to get our risk ratios and odds ratios. And remember, the increased risk ratio for men was 1.34. For females, it's 2.43. So girls who were bullied at an age of less than 12 were 2.43 times more likely to report being always blue in the past month at follow-up in 2015. So remember, they were bullied in 1997, the follow-up date is 2015. So there is a much stronger association of the relationship between bullying and, at the later time point, reporting being always blue in the females. In other words, bullying in the females appears to have a stronger effect on the later reporting of depression or being always blue. This matters because it looks like there is a change in the effect or a stronger effect in the girls than there was in the boys. So we talk about effect modification And this is showing or illustrating an example where the effect of bullying is modified in the females versus the males. Now I've also created another variable which you can also use to explore confounding or effect modification. So just change your outcome to a different time point. And you can still use this variable, and this is a variable related to age in 1997. So how old were they when they reported that they had been bullied under the age of 12? So this might or might not matter, but let's see if there is any relationship between age at the time of the survey and their answers, and the relationship between bullying and being always blue. So I'm setting the new variable to be 1 if they are born in 1982 or before 1982, and no if they were born after 1982. So here we're gonna see the information. So we're gonna compare our tables with our new and our old variables. So these are the years they were born, and so they're indicated as younger if they were born in 1982 or before, and older if it's 1983 and beyond. Now we're going to use this as a stratifying variable in the same way we did for males and females, but here the 1 is being younger and the 2 is being older. And we're creating a matrix 2x2 table for the younger group. And here you'll see the odds ratio for the younger group is 1.84. It's very similar to our original data. And for the older group, it's almost the same. So it looks like there's no effect of age at the time of the survey in relation to bullying and being always blue. Now that might be different if you choose a different time point, so consider that these potential confounders or effect modifiers might look differently depending on when they're assessed. Okay, next we're going to look at urban versus rural. And here the code is a 2x2 table stratified again, but this time by urban versus rural. And we're getting these stratified data. And the 0 is missing information. So urban is 1 and not urban is going to be 2. And so we have our rural population. So here we have our stratified data, and urban is 1, rural is 0, and the 2 is missing information. So you see we don't even have values for many data points there. So we're going to start with the rural population. That's the A, B, C, and D with 4, 291, 17, and 1222. And we're going to give our row and column information the same as we have been. And we have our 2x2 table there, which matches what it was above. And in this case, stratified by rural residents, the risk ratio is almost 1, 0.99, and the odds ratio is identical. So let's see what happens if we plug in the information for rural. Here we have, going back to our original 2x2 data, 24, 986, 43, and 3,927. Using the same row and column names and the 2x2 table, and our odds ratios here are quite different. In this example, the urban population shows a strong increase in the risk. So in the urban environment, children who reported having been bullied at an early age are over twice as likely to report being always blue in the past month, in the year of 2015. That might or might not be the case if you followed up at a later data point. So this is going through the script as created. Feel free to use different variables for your stratification variables. So that would mean changing your third variable here and making sure that you plug in the right numbers for your two stratified odds ratios or risk ratios with these in order A, B, C, and D. So just draw out what your 2x2 table will look for, plug in the numbers there, make sure that you change these names so that you're not accidentally getting the information that you've plugged in from another command. So if you don't change these names, then your new variable might look back on the variables that I created. Okay, thank you.